So we're going to go over a couple more counting ideas that we talked about. So there was Pascal's formula, n plus 1 choose r is the same thing as n choose r minus 1 plus n choose r. So remember why we care about Pascal's formula is it lowers this top number, so it makes it computationally a little bit easier. Remember, we also discussed Pascal's triangle and how to get the entries in the triangle through summing up some other entries. And we discussed the binomial theorem. So that's a plus b to the n. It tells us how to get the coefficients when we expand out a binomial and choose k. So let's look at a problem involving the binomial theorem. For example, use the binomial theorem to find the coefficients. Coefficient of u to the 6th, v to the 4th, in u cubed plus v squared to the 4th. Now we don't want you to multiply this whole thing out. That'll take a lot of time. So instead, you're going to use the binomial theorem, the formula up here. So you're going to replace a by u cubed. You're going to replace b by v squared, and you're going to replace n by 4. So plug all that into the formula for the summation. K equals 0 to 4. 4 choose k. 8, and then a gets replaced by u cubed to the 4 minus k, and then v squared to the k. Now, I want the coefficient of u to the 6th, v to the 4th. Looking right here in this formula, that corresponds to k equals 2. So let's plug in k equals 2. You're going to get 4 choose 2, u cubed, 2 squared, v squared squared. So when you have powers to powers, you multiply. 4 choose 2, u to the 6th, v to the 4th, which is exactly what we wanted to find. So the coefficient is this right here. It's 4 choose 2 would be our coefficient. All right, and I wanted to do one final problem. We're going to do a probability question using a standard deck of cards. So suppose a card is selected at random from a standard deck of cards. And I'll ask two questions. I'll ask, what is the probability that the card is a jack? Well, how many ways could I get, how many cards are jacks? There's a jack of hearts, a jack of diamonds, clubs, and spades. So there's 4 cards out of the 52 cards total, or 1 out of 13. That's the probability. Part B, I'm going to ask a follow-up question. What is the probability that the card is a king or black? So here there's an or, so we need to remember how probability for or works. The probability of A or B, it's the probability of A plus the probability of B minus the probability of A intersect B. So here, let's say A is that the card is a king, B is the card is black. So then we can find our probability. The probability of A, there's 4 kings out of 52. The probability that it's black, half the cards are black, so 26 out of 52. And then finally, if I look at the intersection, the probability of A intersect B, how many cards are black and a king? Only 2 of the king cards are black. So then you can find the probability of A or B, plugging these into the formula. So 4 out of 52 plus 26 out of 52 minus 2 out of 52. So it looks like it'll be 28 out of 52. 28 out of 52 would be the probability.